Hello everyone, I welcome back to my YouTube channel. Myself Parishit Godadiya, studying in Sri Venkateswara College of Engineering, Department of Electronics and Communication Engineering. Subject Electronics Principle and Circuit. Subject code BEC303. Topic Explanation of the Barkhausen circuit. The Barkhausen criterion and introduction. The Barkhausen criterion is a fundamental principle in electronics that explains the conditions necessary for sustainable oscillation in the electronic circuit. It essentially states that for an oscillator is to operate, the loop again must be equal to or greater than 1, and phase shift around the loop must be integrated multiple of 2 pi radius. Defining the Barkhausen criterion. The Barkhausen criterion, named after the German physicist Heinrich Barkhausen, it is a key concept in electronics that defines the condition necessary for the sustainable oscillation in the electronic circuit. It essentially states that for the oscillator to occur, the loop gain in the circuit must be equal or greater than 1, and the phase shifted around the loop must be integrated multiple of 2 pi. Loop gain. The loop gain in the gain of the feedback path, which is the part that allows the protection to the output signal to the feedback to the input signal. Phase different. The phase shifted refers to the change in the phase of the signal as the travels around the feedback loop. Condition for Barkhausen oscillation. The Barkhausen criterion outline the condition that must be for a sustainable oscillation to occur in a feedback circuit. The loop gain, which is a product of the gain and the amplifier and the feedback factor, must be equal or greater than 1. Loop gain. The loop gain in the product of the gain of the amplifier and the feedback factor. It determines how much of the output signal is feedback to the input. Phase shift. The phase shift of the signal around the feedback loop must be one integral or multiple of 2 pi radians, meaning that the signal returns to the original phase after comparing of one loop. The relationship between the feedback and amplification. Feedback plays a circular role in the process of amplification. The feedback loop allows the participant to the output signal to the feedback to the input signal amplifier. The gain of the amplifier multiplied by the feedback factors, decreasing the loop gain. Signal amplification. The amplification amplifies the input signal, increasing its strength. Feedback. The position of the output signal is feedback to the input. Loop gain. The gain of the amplifier multiplied by the feedback factor determine the loop gain. Phase shift crucial role. The phase shift introduced by the feedback network is critical in the achieving the sustained oscillation. The phase shift determines how the feedback signal interacts with the input signal. For oscillations to occur, the total phase shift around the feedback loop must be integer multiple of 2 pi radius. Positive feedback when the phase shift and the even multiple of pi radius, the feedback signal return the input signal leading to the oscillator. Negative feedback when the phase shift is an odd multiple of pi radius, the feedback signal occurs the input signal, preventing oscillations. Gain and phase shift stability. The stability of the gain and the phase shift of the feedback loop is circular for sustained oscillations. If the gain or phase shift varies significantly with the frequency, the oscillation may not be stable or may become unstable. This can lead to the unpredictability of the behavior in the circuit. Gain stability. The gain of the feedback loop should be relative constant over a range of the feedback. In the stable oscillation, phase shift stability. The phase shift introduced by the feedback loop also be relative stable over a range of frequency to prevent oscillations. Application of the Barkhausen criterion. The Barkhausen criterion is the numerical periodic application in the electronic circuit. It is the fundamental of the design and oscillation, which are the statistical that generate periodic signals. The criterion also used to the signal that amplify the filters and other electronic circuit oscillation. Circuits that generate periodic signals. Amplifier circuit that increases the amplifier of the signal. Filters circuit that are related to pass are the critical frequencies. Limitation and assumption of the Barkhausen criterion. The Barkhasan condition provides a simplified route for the understanding oscillation condition. It makes to the certain assumption such as a linearity of the circuit and the absence of non-linear effects. In particular, in the assumption may not always holds the linearity or to prevent the behavior non-linearity. The Barkhasan criterion assuming a linear relationship between the input and output of the amplified. However, non-linear effects are oscillate in the real circuit, not in the loop gain and the phase shift. Shifted model, the Barkhasan criterion of the function and the frequency of the particle higher the harmonic and the frequency condition may not be effective or stable for the frequency. Comparison to other oscillation criterion, the Barkhasan criterion is one of the several criterion used to analyze the condition for oscillation. Other criterion used to the each criterion has their own advantages and disadvantages, and applications depend on the special circuit behavior analyzing. Barkhasan criterion provides a simple and innovative way to analyze the oscillations condition make to the simplification of a assumption. Likewise, criterion a more general and the required criterion the both linear and non-linear system but cannot be the more than complex to apply. Root earthquake criterion based on the coefficient of the character equal to the system useful for the analyzing of the oscillation system. Conclusion. Key concept in review. The Barkhasan criterion is found to be a principle of the explain the condition necessary for satisfying oscillation in the feedback circuit. It highlights the importance of the loop gain, phase shift, and the stability for successful oscillation. This understood essential for the designing and analyzing of the wide range of the electronic circuit, including oscillation amplifier and the filters. Loop gain, the product of gain and the amplifier and the feedback factor. Phase shift, the change in the phase of the signal as it travels around the feedback loop. Stability, the gain of the phase and the relative concept to the oscillation and the frequency to the sustainable oscillation. Thank you for watching my video. Please like, share and subscribe.